So the final working out for this one is on the board. And again, there's no continuity correction we've needed so far because we were starting with continuous data, weights of things. So at no point is discrete ever been involved in here. So everything was continuous all the way through. That's the answer for part B. So that brings us now then on to part C. And part C was when we had to look at the average weight of 25 chocolates and their average weight being between 9.9 and 10.1. And we've got this information at the top of the screen about W. So what random variable are we interested now in part C? It's not the sum of them. What are we interested in now?
Individuals.
Mean, weight. So we're interested in W bar. Okay, the average weight. This is where the central limit theorem comes in. How will W bar be distributed? Central limit theorem says mu and sigma squared over n. Yeah, that's right. So that will be how the mean of the sample is distributed. So here we've got it's going to be normal. Mu is going to be 10. And the variance is going to be sigma squared, which was 4, over the size of our sample,
25.
which is 25.
I thought last lesson you said that sigma squared over n was the whole thing squared.
That's
No.
sigma squared just divided by n. That's
Okay.
right. Okay. So, what is, if you want to write that as a decimal, you can do. You can leave it like that in your calculators. And what we are looking for here is the probability that that is between 9.9 and 10.1. Again, can you make sure that when you're writing these down in questions, you're using this notation, we're writing these down as we're doing here. Again, we can do, if we like, a diagram. This is now W bar. I'm looking at the mean and the values. And again, I want the shaded bit. You can do it as we've done before. You can do it different ways if you want to. We'll meet up again in a minute and see if we all have the same answer.